In this video, we're going to talk about the determinant of a matrix. And let's start with say a 2x2 matrix. Say if we have a matrix, let me call it A, and we have A, B, C, D. The determinant of A, which also can be expressed as A, B, C, D, with these two vertical bars, is going to be A times D minus C times B. It's the upper left times lower right minus the upper right times lower left. And that's the determinant. So the determinant is a function such that you put in a matrix and the output is a scalar. And of course, the scalar is just a number. So that's how we calculate the determinant of a 2x2 matrix. Let me just do a real quick example of the determinant of a 2x2 matrix. Let me call this matrix C. So minus 4, 3, 6, 1. Find the determinant of C. As I said, you can say determinant this way or put the vertical lines. And remember, we had a minute ago, we said it's going to be the upper left times the lower right minus the upper right times the lower left. Or, of course, you could have made this 6 times 3. Doesn't really matter within here which order. Or here could have made this 1 times minus 4. But it does have to be upper left times lower right minus upper right times lower left. And so this is going to be minus 4 minus 18 minus 22. And that's always how you'll do a 2x2 determinant. Once again, remember, it's a function. A determinant is a function that you put in a matrix. So we start with a matrix, and the output is just going to be a scalar or number. Now, what if we have a bigger matrix? I'll do a larger one by example. So let's say if we have a matrix like this, find the determinant of 1 minus 2, 3, 2, 4, minus 2, 1, minus 4, 3, like this. And so the solution, like I said, you could either do vertical bars to represent determinant or just say DET. I'll put the vertical bars. In this case, it'll be a little bit easier to see what we're doing. So here, let's say I have 1, -2, 3, 2, 4, -2, 1, -4, 3, like this. And so what we want to do, again, there are many ways to do this, but I'm going to show one particular way, and then that'll be easy to kind of do them in the future in that way. So we'll go across the first row. We'll go across the first row, and we'll start with the first element in the first row. And so we'd like to do, so we're going to start with this 1 up here, and we'll put this 1 in front. And then we'll cover up the column and the row that contain 1, and we'll write down what's left as a determinant. So we'll go 4 -2, -4, 3. That. Then we'll continue in the first row and go to the next element. Let me leave a space here. I'll write down -2 here. And then cover up that row and that column that contain the -2, and write down what you have left. 2, 1, -2, 3. 2, 1, -2, 3. Finally, go to the last element in the first row. Write that down. Once again, leave a space in front. And we'll cover up the row and the column that contain the 3, and write down what's left. 2, 1, 4, -4, like that. And so there we have it. Now, the last thing we have to do is we have to apply the signs. And we alternate the signs. The first one's positive, so we just leave it as it is. Don't change this one. Then the next one is going to be negative. And then the third one is positive. So it always starts positive, negative, positive. And now go ahead and calculate the determinant the way you normally would for a 2 by 2, the way we did a minute ago. And so we'll take the upper left times the lower right. So it'd be 4 times 3 minus -4 -2. So again, I just took upper left times lower right minus upper right times lower left. And then here, a negative and negative is going to be a positive. So we can just go ahead and change that into a positive 2 here. Then take upper left times lower right. Upper right times lower left. Again, remember, we always subtract that last product. And then upper left times lower right minus upper right times lower left. Like this. And so this is 1 times this, so we can just leave off the 1. So here we're going to have 12. Now this is going to be a negative times negative. That's going to be a positive 8, but we're still going to have a minus in front of that. Then over here we have 2 times 6. That's going to be a negative 2, but to the negative of that. Plus 3. And this is 2 times negative 4. That's negative 8 minus 4. Like this. And we're going to have 4 plus 2 times 8 plus 3 times minus 12. You don't have to go through all the steps that I'm doing here. I'm doing a lot of steps here. You probably don't need to do all this. But in any case, this is going to be 20 here because we have 16 plus 4 is 20. Then minus 36. So the answer is going to be minus 16. So that's the way you do determinant. Again, you can, there are other ways you could do this, other rows you could use, but I kind of took the simplest way to start with. Just go across the first row, start with this one, cover up that row in the column, write down this determinant, go to the next entry, write that down, cover up that row and column to get this determinant. Then go to the last one, cover up that row and column, get this determinant, then calculate it all the way through like this. Now, this is a good method to use, especially if you're going to do things like cross products later, because it'll keep things in the proper order. And so this is a good way to get used to calculating determinants. Now, if you want to know a quick way to do them when you're not doing cross product or something like that, there is sort of a quicker way. And again, but be able to do it this way as well, because sometimes we need to keep things in order. But let me show you a quick way. And this will only work on a 3x3. And so let's do that same problem we have. So say we have to find the determinant of this. And so what we do, write down the matrix, the determinant as we did before. Like this. And now repeat this first column over here. So we're going to rewrite this first column right over here. Then do the second column over here. Like that. And so now what we do, start here. Once again, start in the first row and make an arrow down this direction. First row, first entry, make a diagonal arrow. First row, second entry, make a diagonal arrow. And then third row, excuse me, third entry in the first row, diagonal arrow this way. And now these are all going to be positive. And what we're going to do, we're going to multiply these numbers right along. So we're going to have 1 times 4 times 3. Then go to the next one here. Minus 2, minus 2, 1, 3, 2, minus 4. Like this. Then start with the last row and make arrows up in this direction. And now those are going to be negative, like this. So again, multiply these numbers. So again, in this diagonal here, we're going to have 1, 4 times 3. Again, that's negative. Then go to this arrow here and have a negative in front. Negative 4, negative 2, 1. Then go to this one here. Once again, these are all negatives. This is going to be 3, 2, minus 2, like this. So again, just to review, we go across the first row and make diagonal arrows down to the right. And those are all going to be positive. Go to the last row, make diagonals up to the right. And these are all going to be negatives. Then whatever's along those arrows, just multiply those numbers. If it's a positive ones, we add them together. For these ones here, they're going to be negatives. And then just go ahead and multiply these out. So what we have here would be 12. And 2 negatives is a positive 4. This looks like negative 8, negative 24. Then this is going to be 12, but we have a negative in front. This is 2 negatives will be positive. That's going to be 8, but we have a negative in front. So negative 4 times a negative 3 be a positive 12. So let's see, actually, a couple of these things are going to cancel. And over here, we're going to have 16. That and minus 24, it's going to be minus 8. Another minus 8 gives us minus 16. So that's the same answer we got a minute ago here. So again, this only works for a 3 by 3. That's why I kind of don't put a lot of emphasis on this, because it's limited to a 3 by 3 matrix. This method only works for a 3 by 3. Now I'll show you a 4 by 4, how you would do that. I won't work it out all the way through, but I'll just kind of give you the idea of how you would handle it. And it's the same method that we used here for the 3 by 3 to start with. So let me just, again, I'll just set one up. And so let's say minus 6, 2, 4, minus 5, 7, minus 1, 8, 3, 9, 10, minus 4, 1, 7, 8, minus 8, 13. So again, let me call this B. Let's find determinant of B. And so once again, we can't use that method that we just use, that quick method, because this is a 4x4. We can use that original method that I showed you. And let me go through that. Again, it's the same idea. So let's do this: -6, 2, 4, -5, 7, minus 1, 8, 3, 9, 10, minus 4, 1, 7, 8, minus 8, 13, like this. So let's go ahead and do this. So again, we'll go across the first row. And again, so up here we have a -6. And then we'll cover up that row and that column that contain 6. And then write down the determinant that's left. Then go to the next entry in the first row, which is 2, to put that 2 in front. Then cover up that column, that row, and write down what is left. Like that. And I didn't leave myself much room here, so I'm gonna have to go down the page a little bit here. So go to the next entry in the first row, which is a 4. Then cover up the column that has that 4 in the row, and write down what's left is the determinant. Notice you always keep the numbers in order as they appear in the original. So in other words, when you write these down, don't rearrange any of these. So this is, you see 7 minus 1, 3, 9, 10, 1, 7, 8, 13. Finally, we go to the last entry in the first row, and it's going to be a -5. And write down, first, of course, cover up that column and that row. Write down what's left. Like this. Now, very important stuff. We have to assign signs to each of these. And just like we did for the 3x3, you always start with positive. So the first one's going to be positive. So whatever it was, we keep it that way. Alternate. The next one's going to be negative. Next one's going to be positive. And the last one's going to be negative. Like that. So of course, ultimately this would be a negative, so this is going to end up being +5. So like I said, I'll just set this up. Then now, if you want to calculate these, you can go ahead and do the way you normally would do a 3x3 this way, or like I said, since it's a 3x3, you could do it the quick way. But this is how you would do it. And this is the same idea that you would use for any size determinant.